So here is a second case study, bolt diameter. The mean diameter of the bolt which is manufactured should be say 10 mm to be able to fit into the nut. 20 samples are taken at random from production line by a quality inspector. So you have to conduct a test to check with 95% confidence that the mean is not different from the specification value. Here, this is called a specification value. Okay, this is 10 mm. This is your specification value basically. All right. And we have the sample size which is provided, and we are conducting 95% confidence test. And this is the industry standard, right? Your statisticians, mathematicians, based on a lot of research that they have done in the past, they have come to this conclusion that 95% confidence is a valid number to be chosen for any industry. Of course, if you deal with, say, nuclear power plant, for example, right? If you deal with nuclear power plant, people will not accept 5% error. When I say 95% confidence, 5% chance of you going wrong. If you work with nuclear power plant, people will not give you 5% chance of you going wrong. They might provide you only 1% chance of you going wrong. If it's 1% chance of you going wrong, then the confidence level will be 99%. Right? So these values tend to change based on your management decision. However, in majority of your scenarios, your management would not provide you these numbers. If they do not provide you any number, it is safe to conclude 95% and 5%, because this is the industry norm, kind of thumb rule. Okay. So we have this data in place. As already discussed, we need to understand what is the underlying business problem. Underlying business problem is that if the nut, in the nut manufacturing or the bolt manufacturing, right, if the diameter of the bolt is not 10 mm, the nuts would not fit in. So that's a business problem that we're trying to solve. So once you have your business problem crafted, the next step would be identify on what is Y and what is X. Yeah, that would be the next step. Here, the output variable of interest is bolt diameter. Okay, and the input variable of interest is once again, the specification limit. There is an external standard provided to you all, right? This is one value. If one value is provided, obviously it is population. And the third step here is identify the data type of Y and X. So here, the output variable of interest Y, diameter, is continuous. And the input variable of interest here is discrete. If the output variable is continuous, and if you have input variable which is discrete, then we need to always go back and check this. So if Y is continuous and X is discrete, and here also we are comparing one population with external standard, and that external standard is 10 mm, right? So if that is a scenario, what is the next step? You need to perform your normality test. So the first test here is perform normality test. Any test that we perform within hypothesis, first we need to write down null and alternate hypothesis. Alternate hypothesis means take action, do something. So when would you take an action? If data are not normal. If data are not normal, you try to transform the data. So alternate hypothesis says data are not normal. Yeah. And when you take no action, you take no action if data are normal. If data are normal, we do not take any action. So let's perform this test. I would close this because we are done with this case study. Let me see whether, yeah, bool diameter, we have 20 data points. So this is the case study. In order to perform normality test, there are two steps. One is go to stat, basic statistics, and click on normality test. Another way to deal with this is stat, basic statistics, graphical summary. Just select diameter, click on OK, your job done. You get various parameters at one go. Look at how many, statistics or parameters we got here. If you look at this diagram, it's clear that data follows normal distribution. But we also need to look at the p-value. P-value is 0.820. So here the p-value is 0.820 and this p-value is greater than 0.05. And what was the slang? P-high, null, fly. That means we fail to reject null hypothesis. We fail to reject null hypothesis, right? We cannot reject this. So you need to go with null hypothesis, which says data are normal. Now, if I take you back here, or if you look at this, the output variable was continuous and X was discrete in nature. Bool diameter is continuous and population is discrete. And we were comparing it with an external standard, which is 10 mm. And we also found that data were following normal distribution. If that is the case, if you just go through this flowchart, the next step is, do we know the population standard deviation? So here, sorry, my bad. Yeah. We need to check whether population standard deviation is known or not known to us. So if you go back to this case study, the mean diameter of the bolt manufactured should be 10 mm, right? It's just a value that it has to be 10 mm. But we are not provided with population standard deviation. So if population standard deviation is not known, then what do I do? If it's not known, then you traverse the path of no, and you need to perform one sample t-test for mean. So we need to perform now one sample t-test. And remember, any test that you want to perform, you need to first write down null and alternate hypothesis. Okay, so here, my bad. Here we need to write down null and alternate hypothesis. Null hypothesis says on an average the diameter of the bolt is equal to 10 mm. Null hypothesis. Then you need not take any action, of course. You'd not do anything. It's status quo. You'd follow business as usual. But on an average, if the bolt diameter is not equal to 10 mm, then you have a problem. Then you need to go back, check your machines, fix the problem, because until and unless your bolt diameter is 10 mm, you cannot fix bolt and nut. That's a problem. So now we need to perform one sample t-test. And the navigation to perform one sample t-test is provided here. Stat, basic statistics, one sample t. So let me go back here. If you want to go back to the worksheet, you need to click on this. Just below assistant, you have that up. So we have. So we need to go to stat, basic statistics, one sample t-test. Here, you're not seeing anything. That doesn't mean there is an error. You just need to click on this window, right? You need to click in this window rather. Then you have diameter, select that. Now we need to check the options, right? Before we check the options, do we have any external standard against which we are measuring? Oh yes, absolutely. It is 10 mm, right? And let me see the options. Yep. The alternate hypothesis says not equal. So we have that option there. Let me go to graphs and let us also come up with histogram. There we go. I'll come to the histogram part in a moment. Let us look at this p-value first. For this one sample t-test, the p-value is 0.966. P-value 0.966. Is this p-value greater than 0.05? Oh yes. What does that imply? P high, null fly. That means we fail to reject null hypothesis. And this, in layperson terms, you can say that you accept null hypothesis. But in statistical terms, we test only for null hypothesis. We either reject this or we fail to reject that. So that has been the terminology that has been in use since long. So if you guys look at any statistical book, they will not say accept alternate or accept null hypothesis. The statement would say reject or fail to reject null hypothesis. We speak only in terms of null hypothesis statistically. Okay, but there is no harm absolutely if you say you accept null hypothesis or you accept alternate hypothesis. There's no harm absolutely. Okay. So here, P high null fly, that means you fail to reject, and that implies that on an average, the diameter of the bolt is 10 mm. Yeah, this is one thing. And we also need to look at the histogram. If you want to have the session window open, you just need to click on this. You'll get that diameter. Here we go. So look at this bar that you're seeing here, the blue line, it indicates the confidence interval. And in Minitab, you'll get these kind of graphs, basically histogram, etc. And this blue line is a confidence interval. And if you look at this X bar, this is the true population mean, which is falling within this confidence interval. That means, and you also see that H0 belongs to the interval. Just by looking at this, you can conclude that you fail to reject null hypothesis because null hypothesis is falling within this interval. This is how we can make use of histogram to draw some additional insights. Now let us discuss about one sample sign test. When do we perform this test in the first place? So let me go back to the flowchart which we were using for our discussion, and then we'll come back. This was a flowchart. If y is continuous and x is discrete, and if you're comparing one population with external standard, some historical data, then the first thing that you need to perform is perform a normality test. If the data are not normal, then try to transform. Despite transformation, if the data are still not normal, you perform with non-parametric tests. And in this case study, it would turn out to be not normal. So we'd perform one sample sign test. And when we perform one sample z-test, it was on an average for the mean basically. And when we perform one sample t-test, here also it was for the average, mean, mu, right? But here, when it comes to non-parametric tests, we usually deal with median values, not mean.